NASA just spent $2 billion and their rocket exploded anyway. Here's what happened. During a crucial test, NASA's SLS booster erupted in flames. Debris everywhere. Complete failure. But Elon Musk, he's been warning about this exact problem for years. While NASA burns through taxpayer money, SpaceX is doing something incredible. They're testing Starship directly on the Launchpad, something never attempted before. The cost difference? NASA, $2 billion per launch. SpaceX, $100 million. So why does NASA keep failing while SpaceX keeps winning? Musk just revealed the brutal truth, and it changes everything. Let's dive right in. Musk's prediction just came true in the most devastating way possible. June 26 started like any other test day at NASA. Engineers gathered around monitors. Cameras locked onto the massive solid rocket booster. Everything looked perfect for exactly 2 minutes. Then the nightmare began. The stable white plumes suddenly turned violent. Debris exploded outward. The entire back section of NASA's most advanced booster literally disintegrated on live television. But this wasn't just another test failure. This was NASA's last desperate attempt to save a dying program. You see, behind those closed doors in Washington, the SLS program had already been marked for execution. The White House Budget Office wanted it terminated after Artemis III. This test? It was supposed to prove SLS deserved to live. Instead, it became NASA's public execution. Here's the number that should make every taxpayer furious. NASA has already burned through $23.8 billion developing SLS. That's not a typo. $23.8 billion. What do we have to show for it? A rocket that explodes during ground testing. Compare that to SpaceX. Their entire Starship development program costs less than 2 SLS launches. And while NASA's rocket can't even survive a stationary test, Starship has already completed multiple orbital flights. But the financial horror story gets worse. Each SLS launch cost $2 billion. The rocket itself, $876 million. Ground operations, another $414 million. Mission support, $300 million more. All of this for a single-use rocket that gets destroyed after every flight. Meanwhile, SpaceX launches Starship for $100 million and lands it safely for immediate reuse. The math is brutal. NASA spends 20 times more money to deliver inferior performance. While NASA was cleaning up debris from their explosion, something extraordinary was happening 1,200 miles away in Texas. SpaceX announced they would attempt something never done before, testing Starship directly on the launch pad itself. This sounds simple. It's actually insane. The orbital launch mount was designed to hold a fully stacked vehicle weighing 5,000 tons. Now they're adapting it for a standalone Starship test. The engineering challenge. The mount's central opening is larger than Starship's base. Most companies would wait months for a proper solution. SpaceX built one in days. They designed a custom ring wall system that slots perfectly into the mounting rails, essentially building a temporary test stand on top of a launch platform. The precision required is mind-boggling. Everything must align perfectly or the test fails catastrophically. But here's the twist that nobody saw coming. This improvised solution might actually work better than NASA's traditional approach. Pad A has superior deluge systems, better safety infrastructure, more complete monitoring capabilities than most dedicated test facilities. What NASA sees as reckless, SpaceX sees as revolutionary. This reveals the fundamental difference between these two approaches. NASA tries to design perfection on paper. SpaceX builds, tests, and learns from failure. When SpaceX's early prototypes exploded, they celebrated. Each explosion provided valuable data. Each failure made the next version better. When NASA's booster exploded, they downplayed it, because in their world, failure threatens funding. This difference in philosophy explains everything you're witnessing. NASA has spent years running computer simulations, endless design reviews, theoretical analysis paralysis. Then they build one extremely expensive prototype and pray it works. SpaceX builds multiple prototypes rapidly, tests them aggressively, learns from explosions, iterates constantly. The results speak for themselves. Let's examine the actual capabilities. SLS Block 1 can lift 95 tons to low Earth orbit after spending $23.8 billion developing it. Starship, 150 tons to LEO with full reusability. SLS Block 2, if it ever gets built, might reach 130 tons to LEO, but Starship with orbital refueling has virtually unlimited payload capacity. Think about Mars missions. NASA's current plan requires multiple SLS launches, costing $6 to $8 billion just to get a small crew to Mars. SpaceX's plan uses multiple Starship launches, costing maybe $500 million total. For a much larger crew with vastly more equipment, the performance gap isn't just significant, it's embarrassing. But there's a darker truth behind SLS that most people never hear about. SLS doesn't exist because it's the best rocket. It exists because it provides jobs in key congressional districts. It's a $23.8 billion welfare program disguised as space exploration. Every major SLS component is built in a different state, by design. This ensures maximum political support regardless of performance. The solid rocket boosters, built in Utah, the core stage, Alabama, the upper stage, California, the engines, Mississippi. NASA didn't choose this configuration for engineering reasons. They chose it for political survival. Meanwhile, SpaceX builds everything in Texas. They optimize for performance, not politics. Guess which approach produces better rockets? Here's where the story gets really interesting. While NASA debates whether to continue SLS development, SpaceX is preparing to test two different Starship prototypes using their revolutionary pad-based approach. The timeline is aggressive. If everything succeeds, Flight 10 could launch in early August instead of October. That's a 2-month acceleration just from changing their testing methodology. But the implications go far beyond scheduling. SpaceX isn't just building rockets. They're building rocket factories. They're not just planning missions. They're planning entire transportation networks. Pad B construction is almost complete. They're preparing for dozens of launches per year. While NASA celebrates completing one test without exploding, the future is becoming clear. So here's the question that makes politicians uncomfortable. Why are we still funding SLS? Every technical argument favors Starship. Cost, payload capacity, reusability, development speed. SpaceX wins across the board. Every financial argument favors Starship. We could fund multiple Mars missions with the money we're wasting on SLS development. The only argument for continuing SLS is political. Jobs in congressional districts, contracts for major aerospace companies, political favors disguised as space policy. But those aren't reasons to spend taxpayer money. Those are reasons to stop. NASA's booster explosion represents more than just a technical setback. It represents the death of an outdated approach to space exploration. For decades, a space was dominated by government agencies with unlimited budgets and unlimited timeframes. Cost overruns were normal. Schedule delays were expected. Technical failures were covered up. SpaceX shattered this paradigm. They proved that private companies can develop better rockets faster and cheaper. They showed that innovation thrives when failure is embraced rather than feared. The SLS explosion isn't just embarrassing for NASA. It's proof that their entire approach is fundamentally broken. You can't build revolutionary rockets using bureaucratic processes designed for incremental improvements. While NASA's engineers analyze debris from their explosion, SpaceX engineers are preparing for something unprecedented. They're about to prove that rapid iteration beats careful planning, that embracing risk beats avoiding failure, that results matter more than political considerations. This isn't just about rockets anymore. It's about the future of human space exploration. One path leads to endless delays, cost overruns, and mediocre performance. The other leads to Mars, the outer planets, and eventually the stars. NASA's explosion showed us which path leads nowhere. SpaceX's upcoming test will show us which path leads everywhere. And that's exactly what Elon Musk has been trying to tell us all along. The future belongs to those who dare to fail fast, learn quickly, and build something better. So there you have it. NASA's $23.8 billion rocket explodes during testing. SpaceX builds better rockets for a fraction of the cost. But this story isn't really about rockets. It's about the future of human civilization. When SpaceX launches Flight 10 in August, they're not just testing a rocket. They're proving that the impossible becomes inevitable when you embrace failure as your teacher. The real question isn't whether Starship will succeed. It's what happens when it does. Mars colonies, asteroid mining, interstellar travel. These aren't science fiction anymore. They're engineering problems waiting to be solved. And while NASA debates budgets, SpaceX is already building the infrastructure to make it happen. What do you think? Will NASA finally abandon SLS and join the revolution? Or will they keep burning taxpayer money while SpaceX opens the solar system? Drop your thoughts below. And if you want to stay ahead of the space revolution, hit that subscribe button. Because the next chapter of human spaceflight is about to begin. The universe is waiting. The question is, are we ready to claim it? Ship 36 exploded. Massey test site destroyed. SpaceX should be grounded for months, right? Wrong. While everyone panicked, SpaceX quietly unveiled Pad B, their secret weapon. This isn't just another launch pad. We're talking 10,000 tons of thrust, dual flame buckets, and tech that makes their original pad look ancient. But here's what nobody expected. Ship 37 is already ready for testing. How did SpaceX turn disaster into their biggest advantage? Let's dive right in. So what really happened after that explosion? The answer will shock you. December 18th changed everything. Ship 36 wasn't just destroyed, it was vaporized. The Massey test site looked like a war zone. Fuel lines twisted into metal spaghetti. Quick disconnect systems melted beyond recognition. Even tanks sitting hundreds of feet away were scorched black. Engineers stood there staring at the wreckage. Months of work, gone in seconds. SpaceX's timeline? Completely derailed. Or so everyone thought. But while the world panicked about SpaceX's future, something incredible was happening just 2 miles away. 2 years ago, Pad B was nothing. Empty land. A tiny suborbital test stand. A few fuel tanks scattered around like toys. Nobody paid attention because, why would they? SpaceX was playing the long game. While competitors celebrated each small victory, Elon's team was building something that would make every other launch facility on Earth look ancient. The transformation happened so fast it seemed impossible. Tower platform? Check. Full launch tower? Check. Flame trench that dwarfs anything NASA ever built? Check. And then the orbital launch mount arrived. But here's what nobody understood at the time. This wasn't just construction, it was strategic warfare. Pad B isn't just another launch pad. It's a technological revolution disguised as infrastructure. Those dual flame buckets, they don't just handle exhaust, they weaponize it. Traditional launch pads try to contain 10,000 tons of thrust with what amounts to a steel plate. It's like trying to stop a freight train with a sheet of paper. Pad B's approach is different, completely different. The flame trench channels that incredible force underground, then splits it into 2 controlled streams. The result? Pad A takes a beating with every launch. Pad B, it gets stronger. But that's not even the best part. 10,000 tons of thrust. Let that number hit you. That's not just double what existed before. It's entering territory that makes the Saturn V look like a firecracker. Version 3. Starship will stretch 150 meters into the sky. Current infrastructure is already crying for mercy. Pad B was designed from day one to handle these monsters. And smile while doing it. SpaceX's target? 25 launches next year. Sounds impossible? Within 4 years, they're planning 400 launches annually. That means multiple Starships launching every single day. Boosters reused every hour. Your brain probably just said, impossible. Pad B says, hold my beer. While debris from Ship 36 was still being swept up, Ship 37 sat waiting. This V2 prototype had already passed its cryogenic test back in May. Engine installation? Nearly complete. But here's SpaceX's genius move. Ship 37 represents old technology. V3 prototypes starting with Ship 39 will pack Raptor 3 engines and revolutionary improvements. So why not test the old stuff on the new infrastructure? It's brutally smart. If something goes wrong, they lose outdated hardware while gaining priceless data. If everything works perfectly, they just accelerated development by months. But there's another layer to this strategy that nobody's talking about. The similarities between Massey and Pad B aren't accidental. Structural supports match perfectly. Utility systems connect seamlessly. Even the quick disconnect interfaces were designed for instant compatibility. Ship 37 doesn't need a single modification to test at Pad B. It's plug and play at the highest level of engineering. This isn't coincidence. It's planning that would make chess masters jealous. While everyone focused on the flashy launches at Pad A,